This recording is for the project on measuring the width of the Kenai River, and it's a satellite photo. Obviously you see Kenai Peninsula College on the left, and here's the Kenai River. We were on the bank probably somewhere around here, and then we walked along the bank those 200 paces to about here perhaps, and we measured across, and there were a couple of signs right on the bank on the other side that we measured to. So we measured this way, and then we measured that way, and then to the other sign in a very similar fashion. From what we saw would be this here. That's actually the end of that little island that you saw in the middle of the river. Here's one of the guide boats. Lots of fishing going on in the Kenai River. And of course here you see the near bank, so that's where we had our baseline, and somewhere over here is the sign that we looked at. And so that's me measuring at one end of the baseline. You see the river on the right hand side here, and then here's the trail. And this is the device I used. Very simple. Just made myself 90 degrees on here, and then I measured with these pins here. That would be the baseline, and then I have a third pin that would measure across to the sided sign on the other side. And there it is, it's a little no trespassing sign. And then we went to the other end of the baseline, and I repeated the same kind of measurement. And there again, I believe you can see the difference between this image and this image, that we have a couple of quite different perspectives, and that gives us the triangle. These are the measurements that we took. So, as I said, we looked at two signs. We paced 193 paces. There was a student with me, and I counted 200 paces. That's when I stopped. I stopped exactly at 200, and he counted 193 paces, so basically the same. We have 2.5 feet per pace. That's what we mentioned afterwards with a measuring tape. And then I measured angled 75 degrees and 70 degrees for one of the signs, and for the other signs we measured 50 degrees and 90 degrees. The second one here I kind of find unfortunate, because that actually trivializes the problem, as you will see when you do the calculations. The second one, that's a typical any kind of triangle, and that's the idea, that you can use any kind of triangle and determine the height of that triangle. In this case, the height would be the width of the river. Okay, this is the geometry that you'd be using. So here is again the river, and I can turn us here so we can actually look at it as we usually do. And we would say, well, this is the baseline that we measured the 200 paces respectively, of course, in feet. That's the angle A that I measured a couple of times. That's the angle B we measured a couple of times. And that's the height H that we need to determine. In the process, I would say, at least for one of the measurements, determine what the angle C is. That should take half a second, since you have given the angles A and B. And then you can determine either the side B or the side A, either one of them or both of them if you want to do the calculation twice. And then when you look at it, now you have the side B, probably through the law of sines, and you have the angle A, and you have the height H, and you will figure out what the height is of this triangle on the left hand side. That I leave up to you to do the trigonometry on that. It's really basic at that point too.